So our topic at hand today is going to be light-duty diesel diagnostics. So I didn't want everybody to think we were working on big rigs here. This is going to be your lighter duty stuff, like your 3/4 ton, 1 ton pickup trucks, Sprinter vans, that sort of thing is what we're going to discuss. Because there are differences. If you're generally a gasoline engine tech and you don't really work on diesel vehicles, there are some differences. There's a lot of similarities, especially nowadays with all the emissions controls and everything, but there are some differences. So what is the difference between them? So we'll talk about a couple of them. So they both need the same four main ingredients to run. Of course, they need air, they need fuel, they need compression, and they need some sort of an ignition source. Now, how they do so may differ. For example, the fuel is going to be different. So gasoline is a petroleum product that's more refined than diesel. It also has less energy available during combustion, and its auto ignition temperature is higher than diesel at 475 degrees Fahrenheit. Diesel is also a petroleum product, not as well refined as gasoline, as you can imagine. It has more energy available during combustion, and its auto ignition point is lower at about 410 degrees Fahrenheit. Compression is going to be different too, because compression is basically how a diesel engine works. So gasoline engines compress the fuel and air mixture before igniting it, then with a spark. Compression in a gasoline engine is generally going to be around the 100 to 150 psi range per cylinder, could vary. Diesel engines, however, use compression to compress the air charge before fuel is mixed in. So the superheated air then ignites the fuel, auto-ignites it basically when they inject it. Compression in a diesel engine can be 500 psi or more per cylinder. So the cylinders are going to look a lot different. The pistons are going to look a lot different. Actually, kind of interesting enough with the modern GDI engines that we have out there, they use an awful lot of the same type of technology, the same type of injectors, like the piezoelectric injectors we'll talk about here in a little bit. So in a gasoline engine, of course, we know the combustion chamber, the area for combustion is much larger than it would be on a diesel. We see in this case, it's almost like a Hemi, so it's like a hemispherical chamber. But you're going to have a lot more room in there, and the compression is going to be a lot lower. Whereas in a diesel, the piston's basically the combustion chamber. So it's going to go and it's going to squirt it right into the pistons. There's a very small space in there. Like I said, over 500 psi it could be. So it takes place in the piston itself, and then it just kind of moves out from there and pushes the piston down. So a little bit different. So speaking of injection and fuel injection and diesel fuel injection, what types of systems do we have out there? We have a few different types that we're going to talk about. So common rail injection on GM Duramax and the Dodge 5.9s and 6.7, they use a common rail injection. Uses high pressure fuel provided by a camshaft driven pump, and it is electronically controlled. Of course, we have a multitude of sensors all over the place and things of that nature. 26,000 to 30,000 psi injection pressures can be used for a cleaner burn. They're a little more complex than some of these other units we're going to talk about as well. Each injector has an electrical connector and it's high pressure fuel added, like I said, in the tens of thousands of pounds. You got to be very careful working on these when they are under pressure, because that can cut some stuff, including hands and stuff. So you got to be very, very careful working around high pressure systems like that. Here's kind of a layout of that. So like we said, it's a common rail, and then it just goes into each individual unit, and it is usually a steel line or something of that nature, something metal. So it will provide that high pressure there, and it's also got a feedback into the system as well. Crank sensors, cam sensors, all the usual sensors that you would be used to on a gasoline engine is going to be in there, and it's going to be used to control the injector pulses. So that's common rail on those, and that's like a standard type poppet type injector. Then we have on some of the older Fords, like the Navistar Power Stroke 7.3s and 6 liters. They use high pressure motor oil to magnify the fuel pressure. So it's electronically controlled once again. It's got all your same type of things. The fuel pressure range in this case is going to be much lower. Like we said, 45 to 65 psi, kind of like around what you're going to get with a standard gasoline engine. Of course, now with gasoline direct injection, it's higher. But on a standard injector that we'd be used to back in the day, that would be about 45, 65 psi, somewhere in there. And then, of course, like you said, the high pressure oil amplifies it. So that'd be in the 3,000 to 3,600 psi range. So how does this injector work? It's a little bit different. We got a cross section in here. And the main components of the injector assembly are going to be the solenoid, the oil chamber, the poppet valve, the intensifier piston, which is down here, and the oil is going to press on that. The fuel chamber down here where the fuel goes, and then the nozzle down at the end. So if we were going to make this work, the oil will go into the oil chamber. It's going to push up on this poppet valve. It's going to go into the chamber. And when it does, it is going to push down this intensifier piston. The intensifier piston then, due to hydraulic pressures in there, it's going to convert it to about 21,000 psi of fuel pressure coming out. So we got a large area here. It's going to pressure on the smaller area here, and it's going to increase the pressure of this fuel before it opens up and sprays out. So the fuel chamber is going to be there. It's going to push on the nozzle and push it up. All right, so we can see how that works. On the Ford 6.4s and 6.7s and some other newer engines, they use high-pressure common fuel rail, electronically controlled, but in this case, they use a piezoelectric fuel injector. So they use this on some of the gasoline direct injection vehicles as well. So it has an electrical connector on the injector, high-pressure fuel going in, about 26,000 psi, and then piezoelectric coils to control that. So these look a little bit different. They're a little bit longer than you got. So you have your piezoelectric activation up here. We're going to show how that works. We have stroke amplification down here, so it's going to use another type of, like the oil amplification. We're going to use mechanical amplification down here, and then hydraulic controls down the bottom, and then fuel atomization down at the nozzle. So how does this kind of work? Well, a piezoelectric coil, piezoelectric stack, is going to be, it's going to work kind of in the opposite direction of a NOx sensor. So a NOx sensor is a piezoelectric stack, and when it vibrates, it generates electricity. So in this way, we're going to add electricity to the stack, and it's going to make mechanical movement. So it kind of works in the opposite way. So here's our stack right here. And when I apply pressure, you notice how it expands, or apply electricity, it expands. And then remove the 12 volts and it retracts, and so on and so forth. So every time that happens, it's going to expand and it's going to pump. So that's going to then push on this part, which is our intensifier. So once again, we got a small, large area here, small area there, goes down in force. We'll have some stuff in there, and it's going to push on it. When there's nothing in here, it's just going to kind of sit there and not do anything. I got a lot of animations here. But when we add fuel in here, into this chamber, it is going to push on that. It's going to hydraulically couple them. And that will give us a longer stroke. So we have a small stroke here. We have a much longer stroke at the other end. It's going to push, and we're going to get a much longer stroke down there. And that is going to increase the pressure going on down in here. So high pressure fuel goes in. It's going to push down on the piston. And then when it pushes up on the piston, it releases. Or when this pushes down, it's going to close it off, and it's going to allow it to spray. So it's going to look kind of like this. Nozzle there. There's our nozzle there, closing the system. Got a spring to hold it closed. And then when we allow the diesel fuel in there, it's going to go around. It's going to push back. Fuel pressure on the control chamber and the tension of the spring keep the nozzle needle closed. But then, when the fuel pressure in the control chamber is reduced by this mechanical or the hydraulic area in here, the nozzle needle is going to open. So pressure keeps it closed. When we remove the pressure, opens the nozzle, sprays the fuel. I'm going to do that a few times. All right. So with these different injector schemes that we have nowadays, we are going to have different things that we might need to do. And now most of our manufacturers are going to have some sort of a coding for the injector quantity adjustment, something of that nature. So go in there. Now, in this case, we're on a Ford, so it's got a 10-digit code on top of the injector. It's also got a QR code up there. Don't confuse the characters like A and B, D and 0, and reading off the injectors. We'll go in there. On the next screen, we'll see the current IQA codes and then select the injector to be programmed. So we'll go in there, say we wanted to do injector 1. We'd go in and edit it, and then we would type in the number that's in there. It gives us a little place where we can type it in, and then we would just hit OK once it's done, and it's done. So we're going to talk more in detail about what we can do with the scan tool here in a few minutes. So this is one difference that you're going to get on a diesel vehicle versus on a gasoline vehicle, right? So I'm kind of gearing this towards the folks that don't necessarily work on diesel. All right, now the other thing, one of the other major differences is going to be your emissions system on the diesel. Now they have some similarities in there, like a catalytic converter and things, but we also have things like DPFs, diesel particulate filters, and SCR, which is selective catalyst reduction. So with that, here's just kind of a layout on a vehicle. So we have our EGR system. We have our variable geometry turbo to change back pressure. We have our diesel oxidation catalyst, our DPF, which is our diesel particulate filter, which we'll talk more about in a little bit. We have a NOx sensor on the systems that have DEF. We have a DEF tank and modules and lines and injectors for that. Need to be warmed up in the winter. Goes through the SCR, and then there's also another catalyst back here and a NOx sensor there. Temperature sensors in and out, so it can monitor what's going on. Same thing with the DPF, temperature sensors in and out. There's a differential pressure sensor in there as well. So that's kind of basically how many of them work. Some work in different order. Some have the SCR, some just have a DPF. So there's going to be some differences across brands. But there are some things that you're going to need to do with that as well. So we're going to talk about that. So exhaust after treatment. Like we said, we have the oxidation catalyst. We have a diesel particulate filter, exhaust temp sensors, DPF back pressure sensors, hydrocarbon dosing valves, all of that. Now, how a diesel particulate filter works at a high level, we have these little gnomes in here, and they collect all the particles and store them. So basically, that's what happens, other than the gnome. So it comes in, collects the particles. Then when the particles fill up to a certain point, it can tell the flow, how much flow is going through there. And if the flow is, the pressure difference is too great, then it is time to burn that soot off. So in my mind, the first time I heard about this, I'm like, this is pretty wild, right? So it collects all this bad stuff. It collects all the soot. And then instead of just allowing it out the tailpipe, driving it, putting it in miscellaneous places where I'm driving it, we're going to collect it all in one place. And then when it's time to get rid of it, we're going to burn it all off in basically one place. So I don't really know how that's helping at all. It's helping at the tailpipe when I'm driving, but then as soon as I'm doing a regen, all that stuff's going back in the air. So I don't know. Seems kind of interesting to me. So one thing that can happen is they can plug up with soot. If you don't do a regen, if it doesn't drive to get hot enough to do a regen, anything like that, it will clog up, and then you'll end up having to replace it. Now, we're going to talk about in a little bit, you might even get a code for that. And that code might not allow you to do a regen once it gets to a certain point. So we'll talk about that too. So we have things, different types of regens. Speaking of that, so we have a passive regen. So when the DPF temps are high enough to burn the soot from the DPF without needing extra fuel, it's only going to happen under high load situations. Active regen can be initiated by the PCM or by a scan tool. Extra fuel is added to the exhaust to raise DPF temps to approximately 1,025 degrees Fahrenheit, and then it'll just burn it all. And then we have a parked regen, which can be initiated by a dashboard switch, or it can be activated by a scan tool. It's used when attempts at active regens are going to fail. So oftentimes you can do a stationary regen with a scan tool too. So we have this whole system here. We showed it a little earlier. Multiple failure points, multiple things that may need to be tested, multiple things that may need to be reset or relearned when I do any repairs on this. DEF systems, AdBlue system, they call it on Mercedes, right? So it's going to be, it's going to have that blue urea in the tank. That may need to be reset when you do it. Injectors may need to be reset. NOx sensors need to be reset. When I do any replacements, when I do any regens, there's lots of resets and relearns that are going to be involved with this that you need to do with the scan tool, which we have a boatload of in the scan tool, so that's helpful. EGT sensors measure the exhaust gas temperatures going in, going out, can measure it whether or not when it adds the extra fuel to increase the temperature going through the DPF. It's going to measure when it goes coming in, where it goes into the DPF, where it goes out of the DPF, and it is then able to measure the temperature differentials and see how it's performing and whether or not the regen's actually working, whether or not it actually needs a regen. Right? So the pressure sensors will kind of work off that as well. Then we have the SCR. which is going to reduce NOx after it forms in the exhaust. So, you know, during normal combustion, you will have NOx as a byproduct of that. So this is trying to reduce that. So it uses diesel exhaust fluid, which is a third urea and 2/3 water. The ECU is going to control the injection of that. And 1 gallon of urea is going to treat about 100 gallons of diesel fuel. EGRs, now we've used EGRs in the past and still do on diesel vehicles, which gives us a 2% decline in fuel economy. However, an SCR system is going to give us 2 to 5% increase in fuel economy, so they kind of cancel each other out, or actually gain us some fuel economy there as well. As the SCR system being on the vehicle allows return to a normal injection timing, restoring the fuel mileage back to where it was. So we would have to change the timing and burn more fuel. Now we don't have to as much because we have the SCR. So in the SCR, we have the catalyst itself, a decomposition tube, DEF injector, DEF pump tank and lines, NOx sensors to measure the NOx going in and out. And some of them have ammonia sensors as well, because talk about that in a minute. So here's an example of a DEF injector. You notice how it does have to be heated, especially in the winter. So we got these coils on it, allows it to warm up. Also, there's the injector wire, and then the line kind of clips on there in the back with that. In the DEF system, we also have plumbing, the tank, the lines, the pump, the coolant heater, the electric heater, and the level sensor themselves. So that's all basically in the tank, and you've probably seen this tank if you've seen a vehicle with SCR on there. You see the big boxes that you might have to buy at the parts store or the gas station, or if you're like where I live, the gas station down the street actually has DEF in the pump. So you just pull up to the pump the DEF in, and there you go. The NOx sensors are going to determine the inlet and outlet NOx readings and tell whether or not that SCR is working. It'll set a code if it's not. Can be used in open or closed loop systems, and they can often mis-ID ammonia with NOx. So the chemical composition of ammonia can be misidentified with these NOx sensors. So if you have too much urea going in, going to generate ammonia, so we might have too much ammonia in there, which could cause a problem, which brings us to ammonia sensors. So they're going to measure ammonia levels after the SCR, which allows much greater regulation of the NOx because we can regulate how much urea is going in there. And it's also immune to other exhaust gases, so it's not going to misread other gases in the exhaust. The only purpose there is to read the amount of ammonia going in the exhaust. So our SCR, how's it going to operate? So like we said, we have our NOx at the beginning and we have our NOx at the end. We have the diesel oxidation catalyst will go first. Then the DPF will catch all the soot. And then once that goes out, we'll have a urea injector to inject in here inside the SCR. And then there's also a slip catalyst on the back end for that as well. So we will have the DPF to catch the soot, urea to reduce the NOx, and the SCR to reduce the NOx. And we're going to measure it in or out and see whether or not it's performing. Now, this is a way, measuring the NOx is a way that we can diagnose these systems and see whether or not they fail. So there is a special tool that's been released recently that one of our industrial DSDs actually helped design. He's our big diesel expert guy. And knowing that when they fail, when the SCRs fail or when the system fails, we will have NOx readings, or we will have the NOx readings go off because of the misrepresented as ammonia, right? So we want to tell whether or not it's NOx or not. So there's a NOx only meter that we have. It's Blue Point branded, and it will tell you how much NOx is in there. So it's kind of a variable of our 5-gas analyzer. So it's a 1-gas analyzer, and it's just looking for NOx. And then there's this little chart here. So depending on what your NOx sensor reading, sensor 1, sensor 2, and what the analyzer would read. So in this case, we got 400 going in, and then we got 40 going out. That means it's reduced the NOx, and the NOx analyzer, if the NOx analyzer reads the same as what the second NOx sensor reads, then that's what's coming out the tailpipe. It's a true and correct reading, so the results are good. Got 400 coming out, 800 going out, 400 going in, 800 going out. The analyzer's reading 400. Well, it's not reading correctly at all. Totally failed. Potentially could be the SCR and slip catalyst. I got, say, 150 on the first reading, 300 going out. NOx analyzer's reading 300. Then it's failed to the low side NOx sensor. 600 to 400. And I got 10 coming out the tailpipe. Then that means the NOx sensor 2 has failed high. 400 parts per million in, 400 parts per million out, 400 parts per million at the analyzer. Means we have a DEF issue. It's not injecting anything, or it's contaminated. And if I got 400 in, 400 out, 250 reading on the NOx analyzer is partially failed, SCR, it could be the problem. Now, these are just sample readings, and it's just a guide only, high, low, that sort of thing. But you could use that as a reference, and the NOx analyzer is the way to measure and see whether or not what part is the problem. So that's a pretty handy dandy little tool. And I don't sell those, but Snap-on does. And if it's the type of work you do, that might just be the one thing that helps you. Let's go on to this. Actually came from customer care. I was sitting on a customer care call one day, and this is where you can call out in San Jose. And if you think you have a problem with the scan tool or whatnot. So this customer was having a problem running on a Dodge, was having trouble running a DPF regen, which they call a stationary desoot, by the way, which some people might not be aware of. So that's one thing. They call it something different than what it actually is. So once we go through, it's going to go through multiple levels and multiple messages. So it's going to try and regen, and when it doesn't regen, it's going to go down, and it's going to eventually get to the point where the customer hasn't regened it, nothing's been done, and now they bring it into the shop because it's got a code. It's got this P242F code, and that is diesel particulate filter restriction ash accumulation. So there's a whole bulletin on this. I only selected a couple different things. But the PCM is going to detect that the ash load of the diesel particulate filter has surpassed the most severe level threshold. It is plugged. It basically needs to be replaced. So progressive damage to the after-treatment system from an engine failure, including but not limited to excessive fuel, oil, or coolant in the aftermarket system, may contribute to a high-pressure related fault. Diesel particulate filter could be plugged with accumulated ash, operating in light load conditions that prevent exhaust temperatures from being high enough to actively regenerate the diesel particulate filter, or if the temperature sensors have failed. So those are possible causes for that. So it's going to give you a whole troubleshooting tree. If there's any DTCs present for the exhaust temperature sensors or exhaust differential pressure sensor, diagnose those first before doing this. 242F is usually the result of a drivability or fuel system failure. This DTC indicates the diesel particulate filter may either be face plugged or filled with ash. If there are any other DTCs, diagnose and repair those first before continuing with this test procedure. So it's going to give you a whole test procedure to go through there. But if you have a P242F, it is probably not going to let you regen the vehicle because it's just gone too far. But if we look into the test, this is a 2019 Ram 2500. There is that test right there, stationary desoot. We also see other things in there like DPF replacement. Let's see, there's another one in there. 2 injector compensation values. So that's another thing you need to use for the injectors. Turbo actuator pre-align and self-calibrate for the variable geometry turbo. So there's a few different things in there that you may need to do for these things. But stationary desoot is in there. Initiates the stationary desoot. The stationary desoot procedure requires up to 80 minutes to complete, plus the warm-up time needed before the desoot begins. For the service information for a complete procedure. Continue. Needs to be in park. Parking brake must be engaged. Vehicle's not moving. Vehicle operating temperature. Vehicle not moving. Fuel level needs to be greater than 4 gallons. Because it does spray fuel in the system to do this. Correct any active DTCs not related to the desoot. Stationary desoot will be aborted if any of the enable conditions are no longer met during the course of this procedure, including fuel level, or if any DTC set which can disable desoot. So that P242 is a good example of that. Also remember, you need a good fuel level. If you don't meet any of these things, it's not going to let it happen. Continue. Must be parked on a non-flammable surface. Spare tire must be lowered and a 12-foot perimeter must be established around the rear of the vehicle because it's going to get hot. The exhaust is going to get hot. See service information for details on how to prepare for the desoot procedure. You would continue through there, and then it would bring you through the actual procedure at that point. Can't go any further with those. Also, DPF replacement, talked about that. So resets the soot load estimate values whenever the DPF has been replaced. The engine must not be running to do this. So if I do have a clogged DPF and I do need to replace it, after I replace it, I do need to do this test as well. So the soot load estimate values will be reset back to factory. You're going to cycle the ignition off for 10 seconds, and you're going to be good to go. Shit like that. All right. So that's my slides. let's go through on the tool. And we'll look at 4 examples. I'm going to go through 4 different brands and see what is available on the tool for these types of things. So we had the Ram 2500 first. We just looked at that. So if we see what's available. Oh, it's behind security link too because it's a 2019. Okay, unlocked. There we go. So we can go into engine here. And you'll see we have functional tests. So let's see, lift pump. That might be important for the fuel injection system. Different system tests, after treatment system performance tests, DEF reductant tank heater tests, high pressure fuel system tests, injector kill tests. Because remember, there's no spark on this, so to kill the cylinders, you gotta kill the injectors. Variable geometry turbo sector gear hysteresis test. Boy, that's a mouthful. Fuel system run-up test, DEF reduction, doser pump override test, pressure line heater test, doser prime override test. All those different things could be used for the fuel system or the after treatment system. Then under miscellaneous functions, we have that DPF replacement again. Reset injector compensation values. You have to do that anytime you do injector work. So let's go in there. Procedure resets the injector offset values following injector replacement. Engine must not be running, so it's probably going to error me out here because in the simulator it thinks it's running. Pretty sure it's not going to let me do any further. Yeah, I guess not. So you'd have to go in and it would reset it. Stationary diesel, we talked about that. Idle shutdown timer adjustment. So on the newer vehicles, they have a timer for the idle. So we can adjust that. That's pretty much that. Let's look in at a component test, see what we have in there. 2500 HD, diesel. So in the engine, so exhaust pressure differential sensor, exhaust gas temperature sensors, we can test those, exhaust pressure sensors. Let's see, NOx sensor tests, SCR module. So different component information on that. It's going to give you the pinouts on the SCR. Turbo actuator, that's important. Turbo speed sensor. Look at that NOx sensor. It gives us all the information on that. Work like wideband O2 sensors. They communicate to PCM over actually CAN bus, CAN J1939 bus. And you can do a DC voltage test on it at least to check for battery. You could check the CAN bus too, I guess, if you can back probe it enough. So yeah, there's our Dodge. Next one we'll do is a Ford. 1-ton Ford. So that is a F-Series. There you go. I'll go to engine again. So in this case, we have functional tests, special functions, DPF parameter reset, power balance test, which will help us with the injectors, SCR, fuel injector quantity adjustment. That's important. We looked at that slide a little earlier where you can come in and you can change them. So you just go in and edit. Then you just punch in the different codes. You program it in. Relative compression test. That's important if you got a misfire on anything. Let's see. Injector electrical self-test. DPF dynamic regeneration and static regeneration. Let's see. We talked about that already. Glow plug monitoring self-test as well. Let's look at if this has a separate one back here. Let's see. Sometimes also there can be engine related systems in there. So in this case, that's not. That's just cruise control. Oops, not there. Guided component test. There we go. Just do that one. There's our 6.7 diesel engine. So exhaust gas temperature sensors, pressure sensors. What about the fuel system? We can look at the fuel pump, fuel pressure control valve, fuel injectors. All right, so these are high pressure fuel injectors, open and closed. Piezoelectric actuated on that one. Reductant pressure heater lines, reductant pumped assemblies, reductant injectors, turbocharger actuators, all these diesel specific tests that you might need to do on those. Let's see, we'll do a Silverado. I'm going to go through all the major manufacturers in North America anyway. All right, so in this case, we got engine. So in this case, we have reduction system malfunction warning service bay tests, pilot injector balance procedure, diesel particulate filter tests are in here, DPF regen enable, service regen, pressure sensor reset, and catalyst resets. And then does this one have a separate one? Glow plug control modules in there as well, if you need to do anything with that. And then as far as guided component tests, 6.6. Diesel emissions control, so DEF injectors, purge solenoids, HC injectors, NOx sensors, all tests for those. Exhaust pressure sensors, temp sensors, mass airflow sensor for sure, turbo vane position solenoid, water and fuel sensor, all the different sensors in there that you would possibly need to test, right? We have all of that available. And then lastly is going to be our Sprinter van. So Sprinter van is very popular all around the world. At Mercedes, really getting a workout, especially for Amazon, at least over here. So in this case, an engine. I'll just pick that one. Functional tests, special functions. So we have injector programming. There's also some output controls that we can do for cylinder deactivation for that. Diagnostic glow plug test. EGR actuator as well. Adaptations. Teach-in after replacement of the DPF pressure sensor. Oxidation catalyst converter. Resetting contamination level of the air filter. Teaching to use DPF. All sorts of different things. Regen right there while driving. Teaching process after replacement of AdBlue metering. Reset learn values for AdBlue metering. Replace component DPF. And then on these, this trips people up a lot. And they want to make sure I covered this as well. So engine-related systems and controls, diesel. AdBlue is here. So a lot of people wonder, well, I can't find anything for the AdBlue system, which would be the SCR system, where we're spraying in the urea, right? Because it's blue. So Mercedes calls it AdBlue. So in here we have miscellaneous functional tests, special functions, like AdBlue return, resetting the fill for the tank, visual leak test, dynamic test of the pump. Might be some actuator tests in there as well for the different metering valves and heating elements and delivery pumps and stuff. So there is a lot of diesel coverage in these tools. So if you're not sure if you can work on them with your scan tool, you may be pleasantly surprised. Actually, let me go into the guided component test too. I didn't go in there. On this year, we don't actually have anything for the 22 Sprinter. That was probably should have checked that. Let's go a little older. Mercedes Benz. Let's try like a 19 Sprinter. There we go. The diesel. There we go. The test would carry over. We haven't gotten up to 22 yet. So boost pressure sensor, SCR temp sensor for turbochargers, water and fuel sensor, DPF there, charge sensor, DPF differential pressure sensor, all these different things that you can test on that as well. All right, and if you're wondering, we actually so this will be coming out in emails, I believe, pretty soon. But we just rolled this out this week. Diesel coverage, specific diesel coverage guide available for any of our vehicles with diesel engines. We also have a couple articles about it. I have a couple other videos I've done a few years ago, episode 29 and 50, right? You can also sign yourself up for training and sign yourself up for technical content on this page. But if we go to the online diesel vehicle coverage guide, it'll pull up a PDF of every manufacturer that we cover. I don't want a tour of PDF Maker. Every vehicle that we cover, so like Chevy, diesels, Ford, everything that we cover in diesels. It's pretty comprehensive. Tells you whether or not codes, data, functional tests, that sort of thing, special functions, all sorts of things available for our miscellaneous diesel vehicles that we do cover. So that is rolling out shortly. You should probably see an email about that, I would say, within the next couple of weeks, because it is apparently diesel month here at Snap-on Diagnostics. So that is diesel diagnostics in a nutshell. So we can see what kind of different things we have and where to find the different things on the scan tool. And you can be confident if you do have a Snap-on scan tool that you do have coverage available for that. So with that, let's talk about what we have to talk about next week. It is going to be ADOS year. Not only is it diesel month, it is ADOS year here for training. So we're going to roll out our manufacturer OEM specific ADOS training because every manufacturer is a little bit different. They have their little ins and outs and so on. So ADOS 2025, we're going to kind of recap and bring you where we are with the state of the industry before we go into our individual manufacturers the week following. So we're going to talk about recalibrations and different sensors and things of that nature. So join me for when we're going to start rolling this out for the year, 6 and 9 Eastern. As always, snapon.com/OT if you want to join on Zoom. Otherwise, the 6 p.m. class live streams to Zoom and live streams to Zoom and YouTube. And then the 9 p.m. Eastern class is on Zoom and Facebook. So go in there and check that out. If you want to subscribe to our YouTube channel, you can go in there and scan that QR code, and that will bring you to our YouTube channel and subscribe you automatically. Previous live stream topics, if you want to see any of the other live streams in this series, they're readily available for you for free. Everything from our original ADOS class. It's been a little while since we talked about ADOS. That's why we're doing it this year. So ADOS all the way up to our OEM-specific training through Subaru and everything in between, including this is episode number 103. It's being recorded there right now. So we'll be able to see that in there. Also, if you want to hear anything that we're coming out with, for example, that diesel coverage guide, I'm sure that'll be in an email. SureTrack blogs, Tech Focus articles, new product releases. So if you want to sign up for our email list, if you don't have it, scan that QR code and you will then be on our list. Next, it's going to be time for questions. But before I do, really quick, I just want to mention that my buddy Keith also does training. Live training every Wednesday is on Zeus, and every Thursday is on Triton and Apollo Tools. 4:30 Pacific, 7:30 Eastern. Go to snapon.com/OT to sign up for that on Zoom. So let's take questions here. I got one on Zoom, and I got a couple on YouTube. So if you do have a question on Zoom, just make sure you use that Q&A button. I'll get to that. And then on YouTube, make sure that you go to the YouTube comments or chat. So let's see on Zoom. Diesel emissions is under warranty. Probably not all the time. It's not going to be under warranty for the life of the vehicle, right? So some of these diesel trucks can get up to hundreds of thousands, 250,000 miles, 300,000 miles. Yeah. So right now it'd be under warranty. Probably not going to be under warranty for the life of the vehicle, right? And then, of course, they also have issues where you get codes and stuff like that. So yeah, I mean, some stuff could be under warranty for sure. Like I know on my Subaru, I had a 10-year warranty, 10-year, 100,000 mile warranty on the Cat, but it's over 10 years old now, so could get those vehicles with the high mileage vehicles for sure. There we go. That's your Simon. All right, on YouTube, the Winton says hello, welcome, thank you for joining us. Motorhead1 says CP4 Bosch injection pump disaster. There you go. So I guess there's you've been running into some problems with those, I guess. Craig English says, when should one do a stationary DSUT test? So it's not really a test. It's a function. I guess you could call it a functional test, right? So that is whenever the catalyst gets to a certain level and it's been under low load and it hasn't been able to regen itself driving down the road, you would then do that stationary DSUT test to clean out the DPF for that. So that's when that is. Mark Osborne asks, will this cover the UK? So I know you don't have F-150s and the big engines over there, but a lot of the things I discussed here will cover systems that you have in the UK too, right? They have direct injection. They have piezoelectric injectors, so I talked about that. You know, the all the SCR systems, the AdBlue systems, all that stuff's over in the UK too. So it's going to cross. It's going to be very, very similar. I know we don't have the small ones like the 1.6 liter whatever's over there, or like the Ford, the little diesel engines and the Ford Pumas and stuff like that over there. We don't have that here. So my tool doesn't cover that here, but over in UK it does. So the Ram 6.7, that would be the same back and forth, Mark. So I see you just asked that too. So the Ram 6.7 would be the same no matter where you are. It's going to be the same type of system. The emissions might be slightly different over there, but by and large, the functional test will be the same because we cross over with that. So for sure. Let's see, we got a couple more on the Zoomy Zoom. Let's see. Let's see. 2019 Sprinter 3-liter Triton D10 won't clear oxygen sensor DTCs. Any suggestions? So it won't clear the DTCs, I would say, if there's a problem with them. So not sure what you've done for testing on it. Yeah, really not sure what you've done for testing on it so far, just with that question. So usually when it won't clear the codes, it's just because there's, I guess, something wrong with it, right? Not sure if there's a relearn on that. There may be a relearn on it. Sure, I could probably take the time right now. Let's take a look. Why not? Pull up 2019 Sprinter, which I think I should have right there. Oops, I didn't mean to do that though. Let me back up here and start again. It is going to try and not simulate. Let's see, pull Sprinter, first one, 3-liter. There we go. Oxygen sensor. Let's see if there's any resets in there. Let's see, rotation. Sensor. NOx sensors. Teaching the catalytic converter. There we go. Teaching process and replacement of the oxygen sensor upstream of the cat. So if you've replaced it, process will teach the oxygen sensor upstream of the catalytic converter after replacement. So if it's the front one, there is a reset for that. Let's see. And it's probably going to error out because I can't simulate that. But, or maybe it will go through it. 10-second countdown. There we go. Yep. So, yeah, it's just going to cycle me through. So, yeah, if you replace that oxygen sensor, you will need to do a reset on that. Also, with that, you would want to check and guided component tests and see if we have oxygen sensor tests there. O2 sensors. There we go. So, the front sensor, anyways, bank one, sensor one. Heater tests and the sensor tests themselves. You can do a DC voltage test on it. So that's, you can just test that and make sure it's working. Not sure if you've done that, but like I said, there is a reset that you need to do after the fact. So maybe that's why. All right, let's see. All right, cool. Glad to help. All right. And then Adam says, off topic, was looking for TPMS tool training, could not find online Snap-on. Is there any? There's very little. I have done a couple classes. If you look back in my YouTube playlist, I have done a couple classes on just TPMS kind of in general. Talk a little bit about the actual tester on the tool. I don't really go terribly in depth on the tool. Yeah, we don't really have a lot out there at the moment, but that might be something I can look into for maybe later in the year. We'll just go a little more in depth on the tool, or maybe I can do it kind of as an aside and then post it to YouTube too. If I don't do it necessarily one of the Tuesday classes, we could just kind of do a training walkthrough of it as well. So good suggestion. We may do that. Andrew says, do NOx sensors have to warm up before they start showing data? I believe on many of them they will, just because they have to get into that range where they're reading it properly. So if you're having trouble reading data from that, that may be it. You just might need to wait a little bit to heat up, for them to heat up. Everything else in the system kind of has to heat up too, right, before it to start working, because the cat's not going to work if it's not hot enough. So, yeah, everything's kind of got to be hot or warm, relatively speaking, with that. Let's see. Mark Osborne says, can a relearn be performed on an EGR valve that has not been replaced? You should be able to, because usually it's just kind of a open and close type thing for travel for the sensor, I would imagine. Let me just look on the vehicle and see if it's there. So you said you had a Dodge, right? Well, of course, that was the first one I did, so it's not on the list anymore. One. Let's see if there is an EGR reset. I mean, pretty much any reset or relearn you can do, even if it hasn't been replaced, it just resets it back to a factory type setting. So let me see if there's an EGR. Oh, they got a lot of different tests in here too. Not in there. System tests. Functional tests. Actually, I don't see anything on the EGR in here, but it depends. I guess it would depend on the vehicle. Dodge is really weird to simulate because they have so many different variants on their ECMs. So your vehicle may have it when you hook up to it, but just by simulator doesn't have it when I go through the simulator. So it may or may not have it. But if it has it, you could do the test on one that hasn't been replaced if you think you need to like reset it back to factory for some reason, for sure. All right, looks like that is it. Lots of good questions tonight. Thank you for that. With that, thank you very much. Thank you for spending a little bit of time with me to learn a little bit more about the ins and outs of some of the differences on diesel. Hopefully, you can see how much solid coverage you got in the tool there. So with that, enjoy the rest of your week. Enjoy your weekend. Hopefully, we'll see you next week for ADOS 2025. With that, have a good night and take care.